Okay, let's start. So last lecture, basically it was a session of assembly program, right? Um, so hopefully now you have a better understanding of how to approach assembly, um, how you can think about it, where it stands in computer architecture, um, and what you can do with it. Like it was a hello world, but we can do like pretty much anything. Similarly to other like higher level languages such as C, C++, and so on. So obviously, it's much more difficult to write complex program, but it is technically possible. Um, and yesterday I sent out some instructions for setting up your environment and some references that might be useful, and I highly recommend it to look at them. Um, so hopefully you already have read all of the instruction, and if not, please do so by the end of this week, because you will hear soon about the projects, homework and stuff. So you need to know about this, and you need to set up your environment and be ready to start writing programs. And the plan for today is again like we do some programming together. And hopefully I can answer some of your questions and so on. Before we jump into the programming stuff, um, do you have any question you want to ask? Do you want me to clarify anything? Some of you, like, seems that you're shy, you don't ask any question. I mentioned that I would like this class to be interactive. So it's don't be shy. Some of you send me email. I still mention that I prefer if you send out to Piazza. And if you have a question, like feel free to ask it here in the class. Um, and this is the way how you can learn about computer architecture. Um, and this is one of the fundamental courses and going to be much more important in the future, because of this new trend in machine learning, and also in some other areas, and soon with quantum computing. Um, Knowledge about computer architecture, building computers, knowing about the whole stack is very fundamental and important skill for you to learn about it. Um, so hopefully you can take the best out of this course and try to increase your learning as much as possible, and let me know how can I help with that. And I'm trying to, like, in this course, switching back and forth between, like, talking about some theory, some higher level stuff, the way how we started by some slides, and now switching to some programming, some practical aspect of this. So this will be going in a way to increase your learning experience and so on. So hopefully that would be helpful. Where can I find the recordings for the lectures on Piazza? The recording, basically, I sent out the link in one of those earlier Piazza messages. You can find it, search for it. Hopefully I get the time to upload this on YouTube, and I can share a YouTube channel with you. So, but you can find the link there, and if not, maybe create a issue, new message, and other can post the link there. Um, any other question?
I was just wondering, like, would you be willing, or like, have you in the past made reviews for like upcoming exams? Like, I don't know, like, I know we're not there yet, but like when we get there.
If you're asking about like how the exam looks like, this is your
No,
question.
like an exam review, like just like a outline of like what would be on the exam, or like maybe some, like I don't know, things to start, like an outline of what might be on the exam.
Yeah, that's a good question. I'll give you some example, but typically the exam um, wouldn't be any surprises. So it is like what you see as a homework, as a project, similarly. So it is not really a surprise. Um, so it would be a combination of um, basically some theory aspect of the course, some basic questions about computer architecture, some programming, essentially, and some more interesting stuff later on when we cover about macro architecture. You will see. So, but definitely it wouldn't be any surprise for you. So you will see examples of it. And to clarify, um, I mean, typically, for me, it's you're learning. What you learn is much important than uh, like the exam. So I care a lot about like your learning experience. I spend a lot of time like trying to figure out, okay, how can I teach this for you that you can get the best. And like in other courses that I taught, I mentioned that I'm also teaching like AI um, and machine learning systems. These are more, you know, high level classes that maybe at some point you will take 500 classes. Um, and but basically, for this, I need to the teaching slide would be different from those, um, and I like no matter what courses for me, like exams are less important than learning. So try to learn, try to maximize your learning. You will all get a very good score at the end. So don't worry about like your grades. Okay, so let's start similarly writing together some some code to see where we will end up. And again, if you remember, we start by a specification. Um, these specifications are simple. And then we write some sort of like C code, and then we try to translate it to assembly. That's that's the way we go. And like for today, like let's just start like by thinking. Let's imagine the specification again. This is very is a hello world again sort of program that we expect to write is like imagine that you want to um, print out like adding two numbers and print out the result in the console, right? That's a problem we want to have, right? So essentially, even two numbers, and like here, like again, the specification has to be precise. This is basically you need to write it without any ambiguity, and like numbers could be, you know, could be anything, any number, but let's make it very clear, right? Make it integer, right? So we want to add them, right? And write the result. This is basically the specification that we have, right? And basically, let's maybe turn it to C. Two number, right? We make this as a comment. This is what we want to write, and in C, you know that. So you need to deal with the console. So you need to include some stuff. And then what you need to do is, again, write a name. You need to define two integer number, right? You need to basically decide about the name of these variables, right? This is one of the decisions that programmer has to make, and this is important, but I would like to point out, like when we go to assembly, one important thing, one of the good best practices that you need to always do, maybe not that relevant for like C, but very important for assembly, because otherwise things may go wrong, and that's basically assignment of variables into register. But let's talk about it when we start writing the assembly code. Like here, I want to use like two variables, like let's say a, it could be like initialized to like, let's say 7, and then like another variable could be like anything like b, like let's say 19, doesn't matter. And then we want to print the result into the console, right? So we print the result. Basically, we want to have integer, right? And then going to the new line. So the result would be like a plus b, right? You could also do some fancy stuff like declare another variable to store the result in another integer, right? I'm sure you know about this, right? Result into like a plus b, and then something like that. Okay, so this is simple. Uh, Hopefully there is no question. It's a very simple program. Um, and we discussed that you can like run it, compile it with GCC already. You know that.
Is there any way you could make the text like a little bigger or like your font size?
Oh, sure. Is it better?
Yeah, I mean, I know it's like you probably can't do it across all the different windows, but
Right. Oh, we did not declare, right? Yeah, let me also, hopefully this is better. Um,
yeah, thank you.
Not sure whether this thing, unfortunately, I don't think that spin would allow me, but these two definitely. Okay, maybe. Um, maybe it's right. So hopefully this will compile. Okay. And here is the result, right? Um, and we discussed about like getting the assembly file from GCC, but again, like this is not what we want to do. We want to write the program ourselves, right? We want to write, we want to learn about MIPS assembly ourselves, right? Okay, then done. See, it automatically recognize the syntax highlighter here, so we can start writing our program with with this very easily, right? Okay. Do you have any questions so far? And at any point, if you feel that, please give me this feedback. And this is very good, very helpful. Like at any point, if you think that I'm going too fast or too slow, let me know. I can adjust, and I would like to adjust. So all of you can learn. Okay. So how we start? Um, Essentially, we discussed that you can use different literals in assembly. Um, some of these convention and also in the documents that I shared, instructions, I put some info um, there, some best practices and so on. I will extend on this if I like find some time. Already spend too much time on this course preparing this stuff, but hopefully um, I'm happy to do more, and hopefully I can provide some tutorial kind, but there are also other tutorials out there you can search and find. But these also, specifically these references I put there, they're very useful. Okay, so we need to basically declare some stuff, right? So we can start by writing the name. Okay. And essentially, you know that this name would be in the text part, and you see that this text part here in Qt Spim. This is where um, you can declare it in your assembly, and you can also put these are like make things a lot clearer. Even like main label means a specific thing for MIPS assembly. This is like where your program would start executing. There are some other literals that we'll talk about it later on, like specifically when you load some data. But let's not worry about that for now. Focus on the main functionality we want to implement here. But for example, in order to like clarify it very clearly, you can declare your main as a global, right? So this is how we can clearly say that this label is a global label, and then you can also, like, when you want to declare some other label as a global, you can also do that in other places in your program in this file, right? But for now, I mean, specifically, these are useful when you want to write multiple methods or more clearly procedure in assembly. This is what it's called. Um, these are going to be useful, but for this program, we don't need it, right? And one other thing that I wanted to mention, like, even though like we could start writing your program here, but essentially, I would recommend, and this is a very good thing to use indenting, right? And indentation in assembly, we'll talk about it, is slightly different. There are different best practices, which is different than like other high-level programming convention. We'll talk about, for example, like it's like all the lines of code that you write is like you put them like below each other. We discussed like there is no like two instruction per line, but also you should align them as a straight line. There is no like multiple intention. Even if you want to like have a if or something, it's not like C where you want to have multiple intention depending to help the readers to read your program more clearly. Here is like a straight line, and the reason because like it executed, there is no specific logic that is the way how people think about assembly is different, and that's why so we don't need those. Okay, so the first thing you want to do is to, obviously we need here like similarly as we have two variables here, we need two registers, and again these two registers, it is important to keep track of it. Not much in this a specific program, but in programs that you might have complex logic, or you might have more than two variables. It's going to become a mess if you don't decide about it, or like document it. Okay, so the first one is, let's say, we want to have A and B, right? We could use any registers here, right? We could use like T1, T2. We could use like S1, S2, whatever, doesn't matter. But let's use maybe like S0 for um, getting the first element, right? Variable A. Okay. And for variable A, we put what number? 7, right? So we use load immediate, and we use 7 as argument here. Similarly, we need to do that for the other one, right? What was the other one? 19. And then you could clarify this is variable B. This is the way how you make sure that you assign these to, you know, that like S0 is A, S1 is B. Again, in this, we want to add them, like, and there's no logic specific to A or B. It's not that much important, but you know that in general programs, it is going to be very much important. Was it 19? Yeah. Yeah. Okay. So what else? Then we need to add up these two numbers, right? And for adding two number, there is instruction where you can use, right? What was this instruction? Add two, right? Where basically you can use any register to as a destination register. In this case, let's say S0, we use S0, 1, S2, right? And then we use A and B, which we know that it's in S0 and S1, and maybe here we I put a reference card, which is a like very nice quick cheat sheet that you can look. It has all instructions, right, and the semantic of each instruction. So it is very helpful in order to know what is, if you were not sure about like a specific semantic of a particular instruction, if you forgot or if you wanted to like see to make sure, like you can have right here, it says that you have destination S and T, and then it put the result adding these two registers and put it in RD. Okay, so this is the right instruction.
What is the difference between add and add-do?
The difference, good question. And is the case where, for example, here it says that, right? So it, for example, some one difference is like about overflow, right? And you can check the documentation again. There are maybe here is the instruction reference, right? Much more detail you can find here about each instruction, and we can learn it together, right? So add U says that add unsigned word, right? And specifically here, we assume that these are unsigned, right? To add 32-bit integers, right? And it says that no integer overflow exception occurs under any circumstances, right? So it doesn't, so when an overflow happens, and you know that it happens, right? If you add too large number that you cannot fit into 32 bits, it would overflow, okay?
Okay, thank you.
In that case, it wouldn't give you any exception, right? And there are some other information you can find about it, right? And this is also the encoding. We discussed about like some of these, not all, but like all of them. You can find the detail of encoding and everything here in this document. So this is the way how you can find and like make sure like you understand, even though like the purpose might be very much the same, but like the detail matters, right? Is exception handling and so on, and that's why you might have different instruction. Some of these instruction also, I have to point out, these are like some of these are not really normal instruction or pseudo instruction. I mentioned that the assembler would translate it into multiple MIPS instructions. MIPS essentially allow you to have some pseudo instructions.
Thank you.
Sure. Good question. And again, like I put like more information here, like go through it and read it. Okay. So now we have the result, right? In here, like you can document also this, put some comments. Essentially, this says that you put S2 to make sure that you follow the track of this, so you know that the result is stored in S2. Okay, and then what you want to do is now you have the result. You want to have have printed out into the console, right? To say that to print out the result, right? So one way of doing this is like using this special purpose syscall, right? So essentially, we know that we need to do syscall, but we need to say the assembler what syscall we want to have, and we know that in S2 we want to print an integer, right? So we essentially want to use print D, right? That was the thing we needed, right? So we need to use a special command until we want to use, we want to print out an integer. So we need to communicate with syscall through setting a specific value to v0. You remember we discussed about this. And in this case, we need to, and you can find like these numbers in the documents that I shared. So we know that we have to tell the assembler through a specific value, and this turns out to be 1. Okay, you can find the table and like learn about other numbers. Like for printing the message, you remember we used 4 last time. Now we use 1. Okay, and then but we also need to communicate what we want to print, right? So you can basically communicate it through, and for any method, here is a OS method, but like even if you implement your own method, you need to pass the argument through A0 to A1 and 2, and later on like higher in through a stack. So we need to so we have the result in S2. So LI is not the right instruction for this, right? What instruction we can use for this? Can anyone tell us? Essentially, we want to transfer the value of what we have in the result in S2 to A0, right? We cannot, unfortunately, like use S2 directly with syscall. We need to like put the result into A0.
Is it LA?
LA is load address, right? But in this case, like is not the address, is the value itself, right? We want to copy the value of S2 into A0, right? And we can like if you didn't know, again, like you could look here, see which one might be suitable for this, and we can like find it. Even if you have no idea like which command, like you can look into the semantic part, right? So this seems familiar because it copy the value, but this is not the right thing you want it here, right? You want to basically move the value of your register into another register. So see, you have a source register and a target register. You want to copy the value of this. So this is the right semantic for this. Even if you did not know about it, you could like scan to find the right command for it. So it turns out to be move is a good thing. Then you copy the content of S2 into A0, and then you say, hey, I want to print this result, and this will do that for you. And then you need to maybe, because here we also had new line, you also want to do new line as well. How you want to do the new line. Again, for new line, you need a string, right? So you need to go and declare it, right? You need to declare that I want a string, new line, and I want basically I want ASCII, a string, new line. This is what I want, right? We discuss about this way of doing this. So we have the string there, and we know that we have to use syscall, and we have to again use a specific put a specific value into 0. And for this, you remember last time how we did that. Do you remember? 4, right? And we also need to tell the address of the message. So so we can use LA to load the address, and here again we need we should put it in a specific place, which is A0. And the address is there, new line, right?
Isn't it ASCII Z, like at the top? Because then we used ASCII Z last time.
ASCII
with like 1 Z and two I's.
Oh yeah. Oh, good catch. Good catch. Thanks.
Yeah, I just wanted to make sure. I didn't know if that was just like a different one.
Yeah. No, good catch. Yeah. Yeah. There are always some bugs to catch. Yeah. So now we have also the new line. I think we have everything, right? But like you see that this code doesn't look pretty because things are not aligned. So you may want to, you know, align these. So this is better, right? And you can also align these comments if you want. These are some like practices you want to follow to make, and again, like these are all for like increasing readability. Okay. And you see that we could not do really this thing in one line of code. We needed like multiple lines of code for even doing this. Where in C we could have this like in one line. But in assembly, no, that's not the case. I think this should be good, hopefully.
Excuse me, Professor.
Yeah.
I had one quick question. I know you mentioned it last time, but what exactly does syscall do again? Is that just sending like asking the system to do the most recent command, or?
Syscall is basically is a specific instruction um, that you ask of operating system. So basically, through which you communicate with your operating system, right? And you ask to execute a specific utility functions. In this case, like printing into a console. So again, like if you think about these, you remember that's a good thing to discuss. Let me share. So you remember we had this input output in one Neumann model, right? And we had some control units, right? What was the other one? Remember?
I don't remember.
You need some sort of a memory, right? And there was some interconnection between these, right? And like we did not talk much about input output, right? Mainly the kind of instruction that we had was communicating between these two by going to memory, fetch a particular instruction, and and execute it with ALU, for example, or some other stuff that you had in your microarchitecture, but we did not like talk about like go and print it in the output. So these communication like with these happens through Syscall. Like, these are for like communicating as one of the functionality through Syscall and through like through a convention that you send a signal through VZO to tell operating system like what a specific utility function you want to execute. Okay. We had one more component here. What was that? Do you remember? So go and please, all of you, I did not see any discussion about like the video about one Neumann model that I shared. I'm expecting to see some discussion. Go and see the video of what I put on Piazza. So that remind you about the one Neumann model and detail of this, but let's go back and discuss again the programming part. But that was a very good question. See, like good question would promote some new thing that you can learn, right? Okay. I think we should be good. hopefully this would run. We can go ahead and test it. Where these things, we can test it like we discussed, like you can use Steam, then was to in order to it gives an error on line specs. No volume. What's wrong with this? What we defined. Oh, see, it's one of those bugs. Result 26, right? And here in C, we also get 26. So like we have confirmation that that basically there is no bugs, at least, unless bugs exist in both of them. But typically having having this way of having like two things in like totally two different paradigms giving us the same result, meaning that it has to be correct. Is there any question about this? And we discussed that you can do, come on, you can do some like, you can load, what was the name? And then you can run to get the result through this as well. And you can also do this through here. See, it sits from here. This is the memory address. I know it's very small. Unfortunately, I cannot. I think I cannot zoom it as far as I know. Yeah. And in the data, also here, like the data pane, and you can also put breakpoints, right? So, for example, let's say we could like run it. And something apparently went wrong, but let's see. Maybe we set a breakpoint to figure out like whether there is a bug somewhere or not, and then we could. Oh, what happened? So we could basically. Maybe we need to clear. That's a strange. let's see what's going on. Okay, these are not important. From this line, the main code is started, and you see or I here, what's going on, why it is not my code, li. We discussed about this, right? This would be translated into or I in this case, because li is one of those pseudo instruction. So, and 16 is S0, right? So you see after we execute this, now before executing this, S0 is 0. After executing, it gets the correct value, 7, okay? The same for S1 is 0. After we execute it, it gets the correct value, 13. And then also we put the result in S2. It gets the and these are the values are in hex, right? Are not in decimal. So it gets this number, and then and this is corresponding to 26, as you know. So now we know that we have the right result in S2, and then we need to put the same into R4 or A0 to communicate it with the syscall, and then we put 1 into V0, so syscall know what to do. So it prints out 26 here. So this is good. And this is a stop telling that you have a breakpoint. What do you want to do? Do you want to abort it or do a single step and continue? Let's do a single step. And then we have this thing, new line. So this went to a new line in the console, and we are done. So we have the result, yeah, it's done. Okay, so it's we got the correct result, and it was executed correctly, and we have our second program written together. Okay, fantastic. Any question about this? And here I mentioned that you can like if you wanted to see a specific register, you can ask a SPIM like what is in, like, let's say in what we use, like S2, or like here you get the result, or like print all reg, you get all register numbers interactively. If you prefer a command line type of thing, which might be more convenient, I don't know. This GUI, at least for SPIM, is not that much convenient. Okay, maybe let's do quickly another another quick program together, what we should do. Maybe let's try a loop. We start, and you see that we start from simpler stuff, and we will go into more complex programming constructs. So you will see as we go on, you will see more complicated program constructs that with which you can build more interesting logics. And you can do things. So now let's maybe the specification should be like what should it be? Should be in what we want to have a loop. There are so many things, but maybe you want to like add a certain let's say you want to add 20 numbers from 1 to 20 together to see like what would be the result of that, right? What would we call it? We call it add. Now, since we want to, or maybe because like adding, you already have that. Maybe let's say let's have it. Print 20 numbers. What 20 number? Consecutive 20 numbers. What consecutive 20 numbers? Like, again, step by step, we want to clarify things, right? Maybe like from like 1 all the way to 20, right? So now it is clear, right? And we can write it very easily. Okay, so we know that we need a loop here, right? And in C, hopefully you know what construct you need to use. Like you have different construct in C, right? But maybe let's use 4. So what should we do? So you know the syntax of this, right? So you need to have a counter. You need to initialize it, right? Initialize it to 1, right? What else? You need to also tell the end of this, right? I want 20. Sorry. And then I want to increase this this counter, right? I want to increase this counter, and yeah, see, we forget how to do it correctly and see what we want to do. We want to print some stuff, right? What we want to print, we want to print these eyes, right? So we can use print here, and we have an integer, and this is the integer we want to print, and maybe like maybe you want to like you know that this would print like all the way. If you want to tell, okay, maybe print it in like one line at a time, so you put new line there, so you can have cleaner printing of these numbers into the console. Is there anything else that we need to do here? I think this should hopefully run. I'm not sure what this says. Maybe it is in the source. Why? But let's run it. What was the name? Print. Right. See? It runs. So it runs as we expected. Now, since we have a implementation in C, we want to go ahead and like implement it in assembly, right? Print 20 in assembly. Let's do it. Okay. Let's do it. Okay. So we now want to have a new construct that we have not seen before, like a loop. Obviously, like there is no loop construct such as C, so we need to figure out like with assembly how we can have this implemented correctly, right? And it's a like again this type of translation is you can think about it how with the current construct that you have in assembly, how you can like have how you could build up something like a loop, right? This is a matter of some thinking. It's not really difficult. And you know that for implementing this loop or any loop, somehow you need to have some branching, and you need to have some comparison, because like here you see that you have you need to check like where you are at the end of this like series, right, from 1 to 20. When you hit 20, so you need to have some checking, and you also need to do some branching in order to somehow simulate the loop. And you can think about it, what happens here, it starts from here, it checks, if it's not, it goes and execute this, and now here, and then it goes again like at the beginning. So somehow you can see already that maybe like this is the way how you can implement for in assembly, because you have this comparison construct in assembly, and you also have branching in assembly, moving to a particular location in your code. So you can use these two type of instructions, two concepts, in order to simulate simulate this. Is there any question? Okay. I presume all of you guys should know C. I mean, yes, yes and no. It's not mandatory, but and the type of questions that you will get, you can figure it, even if you do not know much about C, you can figure it out, like what is the semantic of the code, or we will see. Maybe I give you like in 2 different languages, but we will see. But I would suggest learning C if you don't know. It's a beautiful language. Okay, so let's start. So what we need to have a main here, right? And we need to start off by like deciding about I. This is one thing we know is simple. We know that we have to use a particular register to initialize it and add 1 to it, right? So this is the easiest part of this logic. So we use S0, right, in order to do that. But I mean, you could use anything. You could use maybe T0, doesn't matter. So you load up T0 with this value, like 1, and then you need to basically start thinking what would be the next step. And like we need to like think like, and we can revise it as we go to make it to implement this logic, right? So maybe we start off by comparing whether this is equal to 20 or not, right? So one way of doing that is to think. I mean, is to like when we jump out of the loop, we jump out of the loop when we know that this variable I is greater than 20, right? So maybe we use this command like BGT to compare to branch if greater than a particular variable, like branch greater than. And you can search for it, and here is the semantic, right? So this is, can search for it in the like you have branch greater than 0. You have here, and I think it does not define BGT, but BGT is again like is a particular pseudo instruction which would be translated in branch greater, and like the logic, the correspondence, we'll talk about this later on. So you could transfer branch greater than any value to branch greater than 0. You need to do some transformation, right? Mathematically, we will talk about it later on. So these are like simple translation, but for now, let's assume we want to use this pseudo instruction. So we have this thing, right? And then what we want to do is to put basically 20 into T1, right? Maybe. So we want to put 20 because that's our branch condition, right? Then we want to jump somewhere, right? We want to, because if we look at our code here, if we jump out of the loop, there's nothing, it's just return 0, right? So we need a label here. We can change this into a label like end of loop. And in end of loop, we know that we want to return 0, right? So we already familiar with this, so we could quickly go and run it, right? So we say that we want to return 0. So this is how we can communicate, and then we jump and let's say that we jump to a return address, but don't worry about that for now. So this is basically where our program will end. Okay. Now we are done with the other part of the loop. Now we need to add 1 into T0, right? Because T0 basically maintain the value of T0. But before doing that, we want to print the stuff, right? We want to print to the console because the current value of T0, we want to print it right away, right? So how to do that? We want to, first of all, we want to communicate. We want to tell the operating system that we want to print out this one, and we need to put a specific number into V0, which is like, in this case, is 1. Again, you know that. And then we want to call Cisco. So this would print out whatever we have currently in T0. Okay, so now we are done. Now what we want to do is to somehow like go back up, right? Or even like before this, we want to add one to this value, right? So that's easy. So we add immediate to T0 the value of T0 and 1, right? So this is T0, come on. So this is what it does. Okay. This is exactly what we want to do. Once we add this, we should be able to jump back again, like maybe at this place, because we want to check whether we reach at the end of the loop or not. But how we can jump back there? How we can like jump to a particular location? Is like, first of all, like we need an instruction to go to particular location in the memory, right? And we discussed about this jump instruction J in MIPS, and like you should have J somewhere here. Do you see it?
It's on the right side.
Yeah, right. So you need to give it an address, and it add this address into the PC, and it basically add this. So it moves the PC into this particular location in the memory, right? So this is how it does. So so we use jump to go to a target, but like, where is this target? We want to go there. How we can go there? You should already know, right? How we go there? What we need there? Do we have its address? We don't. So we are doomed. No, you already should know, because we could put a label here, right? We could put a label here, loop, and say that, hey, I want to jump to the loop. Okay? So this would jump to the loop. It's assembly. We don't need a specific number. Assembler does that for us. Okay? So what's going on now, right? In main, we do this. we add, we put this immediate into T0. We have 20 in T1. Here we check whether T0 is greater than 20. If it is, we end the thing. If it's not, we go and print it and then add 1 to it. Once we add 1 to it, we go back and check this again and until we are done. So this should be reasonable, right? But let's see whether it runs or not. Maybe it doesn't, but hopefully it does.
Do we need to have it jump from main to the loop, or will it continue straight through main after the?
That's a fantastic question. That's a fantastic question. Thanks for asking it. No. So basically, it's run straight as it goes. Right. Okay. What else? So hopefully it runs. What is the name? Print. It apparently run, but it's not as we expected because like we needed one more thing, which is new line, right? So, and we already know how to implement new line. We have it here, right? So we going copy paste it here. Where do we need to put it? We need to put it here, but we also need to like have define new line here, right? So we need to have the new line. So hopefully this time put what? Did we do something wrong? What's going on?
Your new lines aren't named the same. You have new underscore line and then new line.
Oh, good catch. Good catch. Good catch. Very good. Good. Awesome. So we did it. Right? So what's not like rocket science was not that difficult. We could do it with our knowing nothing, right? But we did it together. That was good. So we could also do the same again here by loading it up here to see whether we have the console yet. See, we also have it in the console with the new line. So you can also see the whole thing in the console. You could also, I mean, like if you remember, that was a good thing. So let's like make it buggy and see like whether we could find a bug here. We need to load it again, right? And then when we run it, see, it says the instruction reference undefined. But before even like putting this thing, it was strange. So here, see that it doesn't allow us to load it up because of good reason. It's basically because we do not have the text alert here, right? So we cannot find the separation between the data and text part of the code. You know, this is where the data reside and things that the rest also are in the data, but we need to have the text part separated. So the assembler should be able to know and tell it to us, so we can go and run it. And like we need to, like, let's say we need to like debug it. We could run it line by one again. Here it jumps to the main. Okay, so this is the main. You see that it loads 1 to T0. So we have 1 here, we have 20 here in T1, and then here again it was translated to some other instruction, SLT. You can go and see what is SLT, right? So it compares S and T and decide whether it's set it to 1 or 0 depending on whether RS is less than target or not. So if RS registered source is less than registered target, it sets RD into 1. Otherwise, it sets it to 0. And somehow you can like think why does, you will see why it does. It sets 1. Now it chooses number 1. This one at. So this is a particular register that the assembler uses here. So now after executing this, it sets RD into a value, and then it uses branch BNE. And like, if you don't know the semantic of this right here, it branches if these two register is not equal. Okay, it branches to a particular offset, right? So here it branches to particular offset if 1 and 0 at and R0 are not equal, it goes to the end of the loop. This is where we specified in our assembly program, right? and in this case it was not, so it go and add, execute the addu, and then do the OR-I or immediate. And you see already that this is not really one-to-one correspondence with the code, but we discussed like this transformation that the assembler does in order to compile this pseudo instruction to the real MIPS instructions. So in this case, it does or immediate between register number 0 and 1, okay? And then it does the syscall, and in syscall, we have 1 written here, okay? So far so good. Where is this? And now see, the error happens. It says that new line is not defined. And then we check the code and see, yeah, new line is not defined. That's right, because like we did not define it in the data. So we see that, okay, there is a mismatch, and in this case it's easy, okay. Some cases could be difficult. You go and catch the bug, you fix it, then you can, like, if you try to run it again, it gives you the same because it has the same like code in the memory. So you need to basically reload the new code here. So don't try to like change it and like think that this is already affected. No, because again, like when you have changed this is sitting on your system in a particular particular drive, right? Particular part of your own computer, but this is emulator. It has its own, you know, part of the memory. It uses the memory, part of the memory of your computer, but it's like another space, right? So you have to tell this every time when you change the code, you have to load it up. You load it here, and then you run it, and you get the result as a result after you fix the bug. And this is an iterative process, as you know. So hopefully is now clear for you.
Yes, thank you.
Sure, yeah. Do you have any question?
Not off the top of my head.
I got the second program to work, but the first one did not work when I ran it in Qt Spim. But I'll take a look at it.
Okay. Yeah. It should work, right? And the idea is, again, doing this together is to see how we need to approach this type of programming, right? Because it requires different thinking.
Right, and I'm getting used to that now.
Yeah, so somehow you need to think, okay, how you could like reduce like this high level like for loop into something simpler, where you can, you know, with one comparison and some jumping, you could simulate the same thing, right? And like I'm sure you have heard about like in C you also can use goto, right? But it's not recommended and for some good reason. But here like we should use GoTo. That's the only thing we can use, right?
I've never written C code. I'm actually an electrical engineering major.
Oh, good. But
this
even
is-
in electronic, you need to learn C, right? It's useful somehow. You want to code
we use a lot more like C++
C++.
from what I found.
Okay.
I have taken the class on C++, just not C.
Okay. Awesome. Yeah. I mean, the syntax are more or less similar, but
Right. There's some differences that I got to get used to.
Yeah. But I mean, like C, C++ are beautiful. Comparing with the other languages, much prefer this type of like C, C++ rather than Java. These are more precise and beautiful. But
I mean,
anyway,
if I'm going to use Java, I'll just use C# instead.
yeah, that's right. I'm the same line. Yeah.
All right. Well, thank you.
Sure. Yeah. Sure. Anytime. Yeah.
Thanks again.
See you. And if you have any question, yeah, let me know.
Is A0 the only register that can be accessed by a syscall?
A0 basically, yes. A0. So for calling any function, if you want to communicate a value, like send some argument, you have A0 to A2 to send these arguments, right? By default, so basically this is the way how it works. You put the value of these arguments in A0 to A2, like if it has one argument in A0. When you are in the method that you called, it expects, if it requires one argument, it expects to find it in A0. If it expects two arguments, it expects to find it in A0 and A1. If it expects three arguments, they expect it like from A0, A2, A3, right? So like that's the only way like you can communicate it with a function that you call, including syscall, right? Does it make sense?
Yeah, that makes complete sense. Thank you.
Sure. And some of this information are also in like your textbook in chapter 6 that you can look it up, and like it's written very well, so I highly recommend it. But beyond that, I also put some references here again. These are especially this second one is a good one that you can oops, why? I need to check this one, why it doesn't. I will check it out. But this one is very good. I highly recommend it. Okay, sounds good. Let's stop sharing and have a great evening.